if anyone says, well, we're worried about the AI getting deployed, they're taking the wrong tense of that word. It's already here. The Terminator is not going to happen. What is the problem is that when we put too much faith in the AI to make decisions without the transparency or visibility or what we call the explainability of to why it made decisions, we see AI goes horribly wrong.
From EE Tech Media, this is Moore's Lobby, where engineers gather to talk all about circuits. I'm Daniel Bogdanoff. In movies, we're given a very contrasting view of the government. Sometimes they're shown as incompetent, literally portrayed as sloths processing DMV paperwork. Other times, they're performing technological magic tricks, enhancing grainy satellite photos and running them through a facial recognition program, all to save the day at the last minute. Joining me today in the lobby is someone who works with the government to make that techno-wizardry a reality. Steve Orrin is a security expert, chief technology officer, and senior PE at Intel Federal, a branch of Intel that works hand in hand with the US government, working on cutting-edge technology. He's also been named a top CTO by InfoWorld and Executive Mosaic, and is a fellow at the Center for Advanced Studies and a guest researcher at NIST's National Cybersecurity Center of Excellence. Steve, I'm super excited that you're here. What's your hacker/engineering origin story? How'd you end up doing what you do?
So that's a great question, and it's really good to be here, Daniel. It started out, I was in the early 80s, I was a hacker, like a lot of people who are in technology these days. Very early in the technology space, looking about how software protections work, how did the networks first work. Before we had internet, we had BBSs, modem dial-up. And it really fascinated me about how, seeing how things work and seeing how things don't work when they're used in weird ways. And so that was sort of how I got into it. Like most people my age, I had an Apple IIe. I was lucky enough to also have a Hayes modem. And so I could use the BBSs of the time at 2400 baud, as slow as that was. But it was really fascinating to see how things work. And for me, I was looking at things like copy protection. And you had all the software that was coming out on floppy disks that they would want, sort of trial and then buy. And that was the area I focused on, sort of learning how those things worked or didn't work, both for games, which of course kids were really into. But I think my favorite one was looking at VisiCalc, which at the time was the very first spreadsheet. It was a $10,000 piece of software, and figuring out how to get it to run without paying for it or looking at the copy protection that was on it. And of course, once we got it up and running, we had no idea what to do with it because no one had ever taught us about spreadsheets when we were kids. That was for later. But it was just an accomplishment. And it was that sense of sort of experiencing the unknown and sort of trying things out in a very new age. And that's sort of how I got really interested in technology and learning about how to code, because you had to code to be able to get into these things, and learning assembly and learning those languages. And again, none of this stuff was taught. There was not classes for it in school yet. And so you self-taught. And that was the community that we had on the BBSs, on the IRC channels, where we shared information, shared code snippets, best practices. And it was that sense of community that really drew folks in at the early days.
So did you have friends that you would meet with and talk through these things regularly, where you kind of strategize and try and hack through things?
Absolutely. But many of them I'd never met. They were, numbers on a BBS board, or people that you meet in some of the multi-user dungeons, the MUDs of the time. And so we had this virtual community before that was even really a term, where people, we made friends with those folks, and you basically created that sense of community. I did have some friends that I knew growing up that also had a computer and also were trying some of these. So we would also, sort of work together, and again, it was international. That was a really nice thing about it. There were folks in Dallas and in New York and in Jersey where I was, but there would be also people in Finland and in Germany and in Brazil that you would all interact with. So it was an international community that became your friends. And they were all about the same age trying these things out.
Did you ever do the phone freaking thing to talk with them live, or was that you stuck more to the message boards?
So I definitely did have a brown box. I will not confirm or deny whether or not I used it, but I did dive deep into how those phone networks work. Those were, again, an area of fascination at the time, because they were very simple analog systems. That in the back end there was some digital aspect but the front end it was really an analog device. And so having a brown box, which is one of the first foam freaking things, and being able to read the Anarchist Cookbook to learn how to build those systems, that was a fun project.
So I'm really interested to hear your arc from being a hacker where you're trying to break, VisitCalc, a $10,000 piece of enterprise grade software and hacking phone systems, into being someone who is effectively working against that. How did you know that tech was going to be your future and not something else?
So, Daniel, that's a really good question. And honestly, at the time, I didn't. So around the time I needed to sort of figure out what I wanted to do with my life in the late 80s, early 90s, technology wasn't really a career option. I mean, you could work at a bank in the basement someplace and work in corporate IT, but it wasn't really the career it is today. And my other love at the time was biology and research. And so I decided to go the research biology route and do pre-med, and with an eye of being a doctor and doing lab-based research, which again sort of satisfied that same question of how do I go solve big problems or learn the unknown, applied into one of the other areas. And so that was my game plan. And I did the pre-med thing in college. I graduated, did some graduate level research, got published. I was about ready to start med school. And an opportunity came up, just sort of the lucky way things came together, where I had some time between, I finished my research grant and had some time off before starting med school. Someone had some money and had heard of this internet thing and was thinking, I should do a startup kind of thing. He said, hey, Steve, you know this security stuff, you know this internet thing. Why don't you come help? And I thought, you know what? This would be a great way of putting some money aside for expensive med school. And so I did that. In 95, I helped start my first company. And after 3 months, I was in love. And I never looked back. And it really was getting in on the ground floor of what became the first wave of the internet startups. So, we started our company before Netscape went public. So it was really early in the hype scale, if you will. We focused, that first company focused on desktop security, which was at the time something that was woefully needed. And at the same time, we were fairly early because the threat had just only started to emerge of what could happen if someone got into your computer. And we were dealing with early email encryption protocols when email was still a new thing. But I think it was the excitement of the time and getting the opportunity to work with some luminaries and some great mentors. After 3 months, I was all in, and probably took another 2 years to convince my parents that I wasn't crazy about doing this tech thing instead of becoming a doctor.
In a nutshell, what is Intel Federal and what do they do?
Intel Federal, which was stood up about 10 years ago, was stood up with the sole purpose of helping to enable Intel to work directly with the federal government. So for those who've done work with the government know there are special regulations, contracting controls, compliance, timekeeping. There's a whole bunch of controls that go into place in order to be able to do a federal contract. It's not something that just anyone can do. So it's standard tech companies don't operate in the contractual model that a government agency needs, like a Lockheed would do. So standing up Intel Federal really enabled us to work directly with the government so that we could do those joint research projects. And that was one part of why we were stood up, was to be able to help Intel work with the government to actually advance what the government wanted to do. The second piece, and why I was brought in, was to give us a technology focus on the federal government. So not just how do we work together, but how do we help advise the government? And the flip side is how do we translate government requirements back into Intel speak? And that's been part of my role, is designing solutions for the government, but also then working with my business unit leaders and the technologists and the fellows to understand what the government needs and how we influence the roadmap so that the next server, the next client meets the needs of the mission area.
Earlier, you mentioned having mentors, and I hear famed security guru Bruce Schneier is one for you. How did that come to pass?
Sure. So Bruce Schneier, I met back at my first company. We were creating some crypto protocols, cryptography to apply to email and desktop security. And the standards really hadn't been published to the point where they are today, where you just use a standard algorithm. So there was a lot of proprietary out there. And we had picked a particular set of algorithms and looked at implementing them. And we were looking for someone to review what we'd done, to say, is this good? And so we hired Bruce's company to come in and do an evaluation of our cryptography stack. And of course, he came in and beat it up and told us it was crap. And but it was a great learning experience. And he and I just really connected. I think partly because we were thinking differently about the security problem. A lot of the companies he had been working with were looking at, well, how do you create a better mousetrap? How do you create the perfect crypto algorithm? Or how do you apply crypto to this problem? And we had taken an approach, and even in my second company where I continued to work with him, about understanding the problem, understanding the user and how they need to approach the problem. So our first company, we looked at it from how do I make file and desktop and email encryption easy to use, not how to make it the super secure. That has to be a foundation. But if it takes 40 steps to send an email securely, no one's going to do it. And so our goal was, can we make it one step? Can we make it 2 clicks? How do we make it? And I think that really resonated. And he was an amazing mentor to me, helping me understand the crypto world, taught me the algorithms, introduced me to his peers and the environment. And I sat in his footsteps and learned for 4 years everything that he could teach me. And I still count him as one of my key mentors in the early days of my career to help me really get on the right path around security and how to apply securely.
I love that someone came in and said, and beat you up about it and said, you're doing it all wrong. And then you turned around and said, we need more of this.
Absolutely.
How does that sort of mindset play into security and cryptography as a whole? I imagine the world is constantly changing there.
So I think that's part of the benefit of not coming in it from a classic computer science degree, is understanding that you come in not knowing how things are supposed to work, so you can ask the question differently. I found that throughout my career, when I've looked at the problems of whether it be securing email, mainframe systems, or the web, the first question I ask is, how do we solve the problem for the end customer? In the case of cryptography, how would my mom use this? My mom is the user. How would she secure her email? And so you think about it from the end user, whereas oftentimes security architects think about it from the protocol or from the APIs, and they're only focused on how do I solve my small piece of the problem, not how does it fit into a bigger environment. And what I found the successes have been is where you think about your security, whether it be a product, a gadget, or a full solution, is thinking about how it fits in to the bigger enterprise or to the bigger, the workflow of the user. And whether that user is an end customer like my mother, or it's a CFO at a large company, ultimately it's got to fit into their environment or it won't get used or won't get used properly. And I think that's been the key to success in applied security, is coming at it from that different angle.
We'll be back in just a minute with Steve Orrin, Chief Technology Officer and Senior PE at Intel Federal. CUI Inc., a Bell Group company, is here to deliver power when you need it. As a leading provider of AC/DC and DC/DC power supplies, they are dedicated to offering choice, reliability, and ease of access with their products and first-class service. Their goal is to assist you during your design process and provide the right power supplies for your consumer, IoT, medical, and industrial designs. CUI Inc. products and resources can be found through their diverse distribution network or at CUI.com. And we're back with Steve Orrin from Intel Federal. Are there any moments that stand out to you where you look at a situation and say, this is, from a security perspective, a beautiful thing, or you look at it from a security perspective and say, this is an absolute dumpster fire?
I think you see both of those things on quite a regular basis. There are examples when you're looking at sort of some of these security systems that have been deployed, and where they keep in mind of keep it simple, stupid. That's a absolute important tenet, is when you have the complexity. This is one of the things that Bruce Schneier is famous for saying, complexity is the enemy of security. And so when you find simple solutions to big problems where they go at the heart of the issue, and you say that's an elegant solution. That's an elegant way to solve the problem. And oftentimes it doesn't require the development of new math. It's really about figuring out the right place to apply it. At the same time, we see a lot of these enterprise systems and large legacy environments with new middleware that's jumped on every generation. There's another class of middleware. And I've seen some systems in large companies and even in some of the government systems where they had a system that worked 20 years ago. And every time there was an innovation, they just lopped on another piece in front, so that now when they're looking at things like microservices, that poor service, that API has got to talk to 20 different steps of multiple stages of legacy. And that's when you think, well, how do I secure that? That's, there's your dumpster fire, because even if you can secure your small piece of the puzzle, the weakest link is 12 chains back.
Yeah. And I imagine every point there is a weak link.
Absolutely. Yes.
Talking about legacy systems, arguably one of the most legacy systems of all time would be the government. You work a lot with the government. Can you explain the relationship of Intel and the government and the work you do there?
Absolutely. And I think one thing I will start off with is that there's a little bit of a myth, and I think some of that is propagated by movies and by the media, that the government is so behind and the government has got such terrible legacy. Granted, the government does have a lot of old systems, and some of them have been operational for many years. And I think what people forget is when they have a system that works and they keep it running, you've got the F-22 has been around for over 20 years, and it's still operational today, and the systems that support it. At the same time, there's some issues with when you want to try to modernize that. What Intel does, our play in the government, again, because we don't really sell direct to anybody. You buy our stuff through the ecosystem, through the OEMs, from the cloud, and from the integrators. We really help the government understand the technologies and the architectures that they have today and where that's going. What's the roadmap? What's going to be in 2 years? How do they plan for that? And we help them with those big problems. It's not, how do I move data from point A to point B? It's how do I do data movement from the end to the edge to the cloud? How do I secure that data through all of its hops? And because Intel is really inside the client system, the network systems, the core network, and the cloud, it affords us that opportunity to sort of think differently about the problem as opposed to a tactical piece of the puzzle. So a lot of our relationship with the government is in that advisory role. And then the other angle is where we strategically work together with the government to do joint R&D. Think about DARPA programs and be able to sort of push the envelope of what's the art of the possible in the future, whether it be around the next generation exascale capabilities and supercomputers to homomorphic encryption, which is the new big exciting area in the cryptography space with some of the DARPA DeepPrive program, which is trying to advance the underlying technology to support those crypto algorithms. And I think one of the reasons why that's so exciting from two angles. One, it's going to give us properties that we've never had of being able to analyze data without decrypting it. Same time, the underlying math is really, really hard and doesn't run great on sort of generic off the run-of-the-shelf kind of hardware and software. So you need next-generation architectures, next-generation silicon to support these next-generation crypto protocols. So it's the perfect marriage of new math with new hardware to solve a really interesting problem.
Can you geek out a bit with us on homomorphic encryption? It sounds really cool, but I'll confess, I don't think I could explain it to anybody.
Sure. So homomorphic encryption is a model of encryption where you can encrypt your data. And this is the classic examples. I have a database full of data that I need to be able to protect at all times. So you think about today, you have sort of three states of data. You have data at rest when it's sitting on a disk drive, on a SSD in a computer. Data in transit when it's going across the network. And then data in use when it's being processed by the CPU and by memory. For 20 plus years, we've had the appropriate technology to encrypt data at rest and data in transit. You use full disk encryption for your data at rest. You use TLS or IPsec or other crypto protocols for your data in transit. But the missing piece of the puzzle has been data in use. How do you protect the data while it's being transacted upon? And today, we have a set of technologies in the industry. There's a overarching topic for them called confidential computing, which is a set of technologies in hardware and software that encrypt the data in memory while the CPU is transacting upon it. Again, provide that in-use protection. But that still leaves it somewhat exposed in the sense that it's still inside the CPU in an encrypted way, and it means you have to trust whoever owns that box sometimes. There's things we can do to eliminate some of that trust to make it less risky, but ultimately, if I have physical access to the chip, with some advanced techniques, I could pop open the chip and see some data maybe. Homomorphic encryption is a new way of doing things, which is it's a set of new encryption algorithms. The math behind it's been published for a number of years, and there's some great papers out there. But fundamentally, just to high level it's a way of encrypting your data in such a way that allows for you to query the data without having to decrypt it. And so what it means is that using the structure, and it's based on some math called lattice cryptography. It's a mathematical algorithm that works very differently than our existing mathematics. But what it does is it creates a mechanism where you can use the points of the lattice to be able to search for your data set or what you're looking for and be able to get results, again, without having to decrypt the database.
Fascinating.
And that's a very important thing. So if I want to be able to submit a secure query, so think a healthcare database, and I don't ever want the data inside that database to ever get exposed, but I need to enable a clinical trials doctor to be able to say, hey, does this symptom show up in the database? It'll allow them to search it without having to decrypt the whole database. And that is a very powerful value proposition. And the way it enables that is that the query actually, sort of boils down to a set of points that then can be translated into the lattice. And I'm oversimplifying it, but it ultimately allows you to do a query against an encrypted data set. And that means I can preserve the privacy, preserve the confidentiality, even while it's being transacted upon by untrusted parties. And that's the key word there. Normally, I have to trust you and give you access to the database to be able to, because you're going to be able to see the results of your query. Whereas I can now give you limited access to that database. So you can say, hey, does it exist in the data set? And then I can validate, okay, I can decrypt the data that you just need, not everything. And that's a very powerful tool in a modern era where it's between regulated data like healthcare and financial services, nations' secrets in the case of the federal government, and really just PAI in general. If we get here and we see roadmaps, we'll get here in the next 5 or 6 years, data breaches start to become a lot harder if the data is never in a decrypted form. The part of the challenge is at some point the database is decrypted, so that's when the malware goes in and tries to steal your data. But if it never is decrypted, then you can protect that data throughout its entire life cycle. That's the vision.
So in a traditional situation, you would have to more or less give access to the entire database for a single query, which seems like a pretty weak point. With homomorphic encryption, you can basically ask the database and it'll say, yeah, here's the one snippet that we can give you access to, but the rest is going to stay encrypted for you.
Yeah. And even then I can decide not to give you the data, but just give you the answer. Because it's only if you're asking for the data. I can give you a yes, no without ever exposing the data.
I really want to talk more about this with you, but first, let's take a quick break. This podcast is sponsored by Infineon, a world leader in semiconductor solutions that link the real and the digital world, making the IoT what it needs to be: real, secure, easy. The company's wide range of solutions spanning sensors, microcontrollers, actuators, communication modules, and security components create the backbone of each IoT system, unlocking new markets and applications. This makes Infineon your partner for unleashing the power of the Internet of Things. Together, we make IoT work. To learn more, please visit www.infineon.io. And now back to our interview. Speaking of untrusted parties, COVID has been interesting, and we are all working from home now in many cases. I've worked with a lot of engineers who spent time doing R&D work in top secret type places. After leaving those roles, they talked about how happy they were to have Windows in their office. Can you talk about security in the context of working from home?
So Daniel, that's been a fundamental challenge that the government has had to face in the times of COVID, in the times of this pandemic. In the early days, there was this notion that, well, we can't work securely from home, so we're just going to lay people off. Or some agencies had 1 week on, 1 week off for small parts of their organization. But very quickly, a couple of the agencies really got on board to figure out how can we do secure enough at home. And I think the Air Force was really the poster child for this. The Air Force had been working on and has a product that they developed called SecureView. And it's one they developed for their internal use. It was for being able to do top secret and just secret or unclassified on the same laptop, and be able to do that in a secure way that you could isolate those worlds all the way down to the CPU, but also for the network. And they've been using that. And what they did is they rapidly spent the first quarter that everyone was off on COVID working on creating what they call jump kits, that they could take that software stack on that hardware and deliver that to their people to be able to work from home in a secure fashion. And the way they were able to be able to do a certain amount of classified work from home is that they were able to secure those systems, the laptop itself and the network, and be able to apply the right crypto protocols over the network so that they could overlay on their local home environment and be able to do a certain level of classified information from their home. Again, given a lot of other physical security things that they had to go do the checklist to make sure they have no direct line of sight windows and other physical things. But one of the key things is they thought differently. It wasn't, okay, we can't work anymore. We have to figure out how to bring people in slowly. It was, how do we take what we've done securely inside and replicate that out? And I think the Air Force, there's been a couple of great articles about how the Air Force was successful to be able to scale that to thousands of employees around the world and then share that best practice with other agencies. And I think what that's enabling is people to think about, well, how can I do classified work? Again, not the launch codes, but that next level down of sort of these day-to-day activity of writing code for different missions or being able to do IT management on a secure system. And it's that change of philosophy of it, not just in securing the environment, but securing the system, securing the data, and bridging all those things together. So we've seen some good successes. There's also best practices that I think both the Air Force and a lot of enterprises help their employees understand. Securing your local Wi-Fi better. That became a requirement. There was a set of best practices sent out to a lot of government employees about here's what you need to do for your home network. Make sure you have a good WPA code. Make sure that you're locking down with a firewall your local wireless. Separate your wireless from your gaming devices or your smart lighting. All those kind of best practices help to secure the home environment enough to reduce the overall risk. But I think a lot of companies had to do some quick math, some quick risk calculus to say, how do we enable our workforce? Because it's not like 10% of salespeople out in the field. It's not 100% of our workforce that are going to be remote. And how do we change the way we do business in order to be able to enable that? We saw a lot of cloud activity pick up where, okay, I can't trust you. I can't give you direct access to my internal systems because that would compromise them. But I can give you a cloud service that I can secure to give you access to email, give you access to your SharePoint or your documents in a secure fashion. And then we can enforce security on your access to that. And that became the method du jour of a lot of organizations to quickly spin up employees by leveraging cloud capabilities.
So it sounds like Air Force definitely led the charge in the early days. Are they consistently more forward thinking, or are there agencies that you work with that are more shining examples? And I won't ask you to throw anyone under the bus unless you really want to, but are there any areas that you that are a constant struggle for you?
So I would say that you'll find pockets of excellence across every agency, and it's really where they've empowered their people to think differently and to do differently. And so the Air Force is, I think, why we talk about them is they've been a lot more public about it, whereas the other agencies, while they're doing a lot of the amazing things, they don't necessarily put out articles or touted in conferences as much. We've seen amazing things out of all the services, the Navy, Air Force, and Marine Corps, but you don't hear about them as much. I think that the more challenging ones, and it's not because they are more challenging, but because of the nature of their business, when you start thinking about the intelligence community and you start thinking about headquarters DoD, where these are serious secrets that they need to keep, they're obviously much more conservative for good reason. And so it's not that they're being a pain. It's that they have to protect things at a level, to another level of protection, and the people themselves are at risk. And so I think in those environments, they're a lot more conservative for good reason. But even there, and you can see there have been talks given by the Department of National Intelligence. They're still doing amazing things, and they will talk about it. The NSA has published lots of amazing best practices on how to secure systems. They've put out reference architectures. They're working with industry. The recently stood up Cyber Command has a section called Dreamport, which was a whole building set up specifically for industry to come in and collaborate. And so they've thought differently, even in the intelligence side, about how to do outreach. A great example is the DIU, or Defense Innovation Unit, that's out in Silicon Valley, who sold charters to work with startups. They actually, they work with startups to help them get adopted in the government, but also to help proliferate what the government needs to companies that typically don't get time to come, fly out to DC and spend time with Washington.
So the Air Force are just show-offs, is what you're saying.
I would never say that.
If you were to look at the space and you have the government and you have the private sector, is the government ahead of the game and companies are kind of catching up? Where are we on a technical level?
So it's an interesting question because I think it depends. In some respects, and coming at it from a technology perspective, you often think of the financial services being at the forefront of technology, IT adoption. A, they've got the money to burn, and B, they're always looking for the next amazing thing as a way to optimize their business. So financial services is classically on the spear, the front end of a lot of technology adoption, and we see certain other industries that have come close. At the same time, the government is adopting amazing new technologies, whether it be AI, whether it be next generation security technologies, because they have the mission need. You may think about it, their IT systems may seem antiquated because they're struggling to get off of Windows 7 to go to Windows 10. But the latest Predator drones or other mission platforms have some of the most advanced technologies in them. Where I think that you find that sort of the tail and the dog or the head is really when it comes to certain key areas. So the government has always been way ahead of industry as far as it's around security and the risk. They've got the feeds. They understand the threat environment. They are under active attack. And so I think that they are usually ahead as far as their requirement set of what they need to have in order to secure their systems. And what we find is typically industry, financial services, the cloud providers and others adopting government standards or government requirements a couple of years later. So there's that sort of upfront, the government is a vanguard of what's needed. And then we see those same kind of requirements coming out of financial tenders or out of other industries, oil and gas and others, adopting the same standards, the same terminology. On the flip side, when it comes to IT modernization and cloud adoption, it's the absolute opposite. The government's been a little bit behind the rest of the industry. But there have been some examples where that actually has worked in their favor. Industry went whole hog into the cloud and lift and shift, get up there, get everything out there, and felt the pain and went through the pulling it back in. Okay, bringing it back out. Okay, we need to do hybrid cloud. Wait, we should do multi-cloud hybrid cloud. We need to do serverless. So the industry has basically been the beta tester to figure out what works and what doesn't, what's the methodology. And the government agencies that maybe waited, and they probably didn't know they were waiting for a good reason, but they waited, and now they're able to take advantage of the fact, okay, we've seen what worked and what didn't work, and now they can make a more logical shift to the cloud, or at least take advantage of version 5.0 of those services that have worked out all the kinks. And so I think it's actually worked in their advantage on some of that modernization. I think everyone agrees that they need to move faster to modernize their systems to take full advantage of the cloud and of cloud-style offerings and development. But yeah, that's definitely an area where they've trailed the industry, but it may work out in their favor in the end.
Fair enough. The government saw the industries fail and struggle. What have they learned, and where did they finally settle?
So I think that learning hasn't stopped. I think there's still learning that's going on there. But I think where they figured out is when you look at sort of the cloud RFPs and you look at the adoption that they're doing today, you're seeing terms that we only just recently started seeing in the government spaces. The need for multi-cloud support, having a DevOps process that's leveraging DevSecOps built into the cloud development process, understanding that you can have on-prem and cloud resources that have to work together. Those are very advanced if you think about how soon the government jumped on the cloud, but a lot of that's because they looked at industry and saw what worked and didn't. I can tell you now, a lot of the application development going in the government, by default, it's containerized.
How would you describe a container for those who aren't familiar with it?
So a container, it's a type of technology that basically allows you to take an operating system, and whether you're using like Kubernetes or Docker, and put it in a wrapper that is independent of the environment it's living in. And so it allows you to create an application and dump it into a container, and that container and the engines that are so handles the OS interfaces, handles the hardware interfaces. And so it abstracts that away so you can focus on what you care about, building your AI inferencing or building your little widget that does whatever it does, and not have to worry about all the driver support and all the OS calls and all the storage and transport and networking needs. The container itself handles that as an abstraction. And so what it does is enables those agile development so you can develop what you need to. And if you've got a good container engine or a container strategy that handles all that sort of lower level infrastructure and the deployment. That's the other key thing is oftentimes when you were building apps in the old days, not only had to build your functionality, you had to figure, okay, how do I deploy it to Windows? How do I deploy it to Linux? How do I deploy it, on a server or on a client? Containers take care of that for you. So basically you build once and it will allow you to deploy everywhere. That's an advanced concept, that you don't normally learn about until you've failed a couple of times. Again, they're watching what the industry has done and said, hey, wait a second. Container strategy is a really important thing, not just for the smooth DevOps, but also being able to manage it across those complex hybrid environments. And so you're seeing new application development, even on legacy systems, it's all containers first. And then we can look at, if we need to pull it out, because it's faster prototyping, faster time to adoption. And then you can take that same container, and this is the vision, put it on an edge, talking directly to a camera, and in the cloud, and have that same application service the edge and the cloud at the same time. So where we're seeing the learnings take advantage is in the way that they're going about cloud adoption. They've definitely, seen, or and in many cases, they spend time with industry understanding. They go to Wall Street and say, and talk to the CIOs and say, well, how did you do it? And they'll let them know about, here's what worked and here's what didn't. And so I think a lot of government agencies have gotten the advantage of talking to the trailblazers and learned. And also we're seeing the technical talent, the next generation coming in, so that the warfighter that joins the Army today is already been exposed to in college containers and to microservices. And so they're coming in better armed to be able to help the military adopt these new technologies.
You mentioned AI a couple times. Is there a role for AI in cybersecurity, and does it almost become its own attack vector at some point?
So Dan, you actually bring up the heart of the issue. I look at AI and security as sort of two sides of the coin. On the one hand, I think that we absolutely can use AI to get better cybersecurity, whether it be better threat prediction, anomaly detection at scale. Just from the sheer volume of data, you're going to need AI and machine learning to be able to sort through it because no human can. Plus, as the attackers get more advanced in their sophistication, our tools and techniques need to get more advanced. Flip that coin around, AI itself needs to be secured. As we've already seen, there are examples, there are papers, there have been talks at the big hacker conferences about how to hack AI systems, whether it be tricking the end result AI to think a stop sign isn't a stop sign, to poisoning the database, the data set that the AI was trained on, so that you can basically make sure that it's going to be faulty on its exterior. So one example that was shown is that if you're using facial recognition and you want to make sure that your face never gets detected, you can poison the data set such that when the ultimate AI system is deployed and you walk in front of that camera, you're never going to get detected. And that's, again, what a nation state would want to do to make sure they never get, that their agents or a criminal activity never gets picked up. And so we need to look at how do we secure AI from a life cycle perspective, from the building of the AI systems, the training, and the deployment. And so I think, as you mentioned, it's both sides of the coin. I think there's a huge opportunity. We're seeing a lot of innovation happening on securing AI. And I think you can't find a cybersecurity company today that doesn't have somewhere buried in their data set, we use the latest AI and machine learning, because it's just a requirement today.
Yeah.
Now, how much of that is true AI versus just really advanced pattern matching, that will leave it up to each company to tell you. But there are some really innovative companies out there that are doing very interesting AI, especially as we look at threat prediction and threat detection.
It seems like there's a repeat of the same issue with data at rest, data in transit, data in use. With AIs, we have the same thing because we have to feed everything into an AI so that it can analyze it. Is that part of the problem, or how does that get addressed?
So that's a really good point. AI is only as good as the data it's trained on. And as we've seen in a lot of AI deployments that have been publicly put out there and have failed miserably, when you have bias, and bias is a big term, when you have bias in the data set, whether that be if you trained it all on white males from 18 to 25, you can't expect your AI to do a good job of doing human recognition, because that's not representative. The same would be true if you're looking at, you want to be able to train an AI to pick up cars and trucks, but you don't train it on fire trucks. It's not going to be able to recognize it. Or as the classic example of a particular autonomous vehicle, you trained it on red fire trucks, and there happens to be some examples of yellow fire trucks out there. And so it didn't recognize it. Bias in the data set is a real challenge. But at the same time, it's not just about having bad information in there, it's having quality information. The really good AIs are trained on large amounts of good data. And good is defined as having a lot of context and labeling with it. And of course, not having bias built in or having been attacked. So all of those factors come to play that when you want to build these next generation AIs, whether it's for autonomous driving or cancer prediction or facial recognition, what have you, you need to have good, rich data sets that are curated. And inside that curated, they have to have a governance model. And that's why a lot of times when you look at the AI lifecycle, everyone focuses on what I call the sexy part. Let's go train a model. Let's go build a model and recognize cat pictures. But there's a whole back end to that. So that's the tip of the iceberg. The whole back end is the data curation, the data wrangling, as they call it now, to produce the good data set to then train that AI. And that's where the heavy lift happens, but also where you get the good outcomes and the successes.
I was actually just playing with that this weekend. I found a website called Teachable Machine. I think it's like a Google Pilot, and you can upload image sets and train a machine model on it all in your browser. So I did some Google image search scraping, and it was shockingly easy to land it to my camera feed, to land me into different classes by like putting a jacket over my head or shining a light at the camera and just watching the model go crazy. So the data sets seem critically important. I'm really curious, how would you go about poisoning a data set so that it wouldn't recognize your face?
So it's going to be specific to the kind of AI that's going into it. But the examples, and there's some papers from various universities. I believe Purdue has one, and there are a couple others that, it's looking, because ultimately what the AI is doing, it's not training on your face per se. It's creating a digital map of the key points of interest of your face. And so there are two maxims to think about. Number one, it's a known sort of overarching maxim in AI training. For every bad piece of data, I need 2 good pieces of data just to get back to normal. So to undo the bad, not to get good, but to undo the bad, I need 2 for 1 for every bad piece. So with that in mind, the next piece is understanding your face and your cheekbone structure and everything is going to translate to certain key characteristics. And so if I want to be able to have that your face, your characteristics be genericized across a larger set of people so that you get misrecognized, then what you do is you feed the data set with specific images that have a lot of the attributes you have, so that you can poison it or create a generality for yourself. And the way you do that is you use a deep fake engine to create modifications of your face that aren't your face, but have the right attributes. Change the skin color, change your cheek structure just enough so that's within the mean or the average deviation. And then what you've done is you've created 1,000 faces that would all equate to you. And so when you show up, it's going to have a low probability, because the idea is it's not going to say, okay, you're not Daniel, you're Jason. It's going to say, I don't have a good confidence that you're Daniel. That's what you're trying to accomplish. It's going to say 40% you're Daniel. Well, that's not good enough to say that you're Daniel. And that's what you're doing. You're creating a poisoning in the data set that allows you to get away with not being weighted as 95% Daniel.
You almost overtrain it on specific attributes so that when the situation arises, it misclassifies.
Yeah.
Fascinating.
And again, we're oversimplifying a bit, but that's really the technique.
Yeah. On the flip side, a lot of people are nervous about AI being deployed and existing in the world. Is that something people should be concerned about, or is it just a fictitious boogeyman?
Yes. I think both are true. And I'll give you 2 reasons why. Number one, if anyone says, well, we're worried about the AI getting deployed, they're taking the wrong tense of that word. It's already here. Every time you search the web, every time you buy something off the web, your social media, everything is already using a lot of AI, and it's driving the news feeds you see. It's driving what they recommend you buy for your kids for Christmas. It's driving what financial instruments you get sold to be able to do your life savings. Your whole life is surrounded by AI, so that ship has already sailed. At the same time, it's not that it's necessarily a boogeyman. Again, the Terminator is not going to happen. What is the problem is that when we put too much faith in the AI to make decisions without the transparency or visibility, or what we call the explainability of to why it made decisions, we see AI goes horribly wrong. And there have been a lot of examples where good intentions about how do we streamline the process of mortgages and be able to get their times to be able to do approvals down by applying some AI. That is a lofty goal. That's a great goal. You want to be able to give people a response quicker. But what we saw when they implemented the AI and the data sets they used, what they actually did is they disenfranchised whole areas because they used data about crime rates in certain zip codes, or age information about certain individual classes of individual that put bias into the AI. So that when we applied it, it disadvantaged poor, low-income families, disadvantaged minorities. And again, that wasn't the intent of the AI, but it's where it went horribly wrong, because the data sets were opaque to the ultimate user. The company that was using the AI didn't know how the data set was trained. And I think the same thing will be true in all aspects of AI. If we don't have good visibility into what built that AI, and we don't have good controls about the data sets and their bias, we will end up with horrible AI outcomes in a lot of cases. The other story I like to tell is, we don't get to a Terminator by accident. We don't get there because someday it becomes self-aware. But what does happen over time is what I call the death by a thousand cuts. It starts off with, well, I'm going to, it's all good intentions. I'm going to make it faster to recognize a bad guy. Okay, I'm going to use some AI to help augment. Well, I need to be able to use an AI to do tracking better. So I'm going to add some AI there. I'm going to use AI to be able to guide the missile better. So all those steps come to play. And eventually you take more and more of the human out of the loop. And at some point, you get the AI making decisions without a human in the loop. And that's where things can go potentially wrong and where people get scared. And so what's been a really a light of shining on the problem, and a great example is the DoD the Department of Defense put out their AI ethics strategy and said, we're going to develop AIs, and here's how we're going to do it. And here's the ethics upon which we're going to build AIs. And they published it. And they published it in an open form. You can go to the website and download it. And that was a different way of doing things. They said, here's how we're going to do it. And here's the ethics we're going to use to make decisions about when to use AI. And I think it's a great example that corporations should adopt. They may have different ethics for how they want to use it, but it's about visibility. And so being more forthcoming about how they're going to use AI and what they did to build it and what are the controls they put in place is how we're all going to become more comfortable with it. So if every company you work with, just like you have the little privacy statement on the bottom of the page, there should be a little AI statement of here's how we built the AI that's going to tell you which toy to buy your kids for Christmas. You should know that. You should know how did the vendors have undue influence on that? It may be okay, but you should be able to know that.
You mentioned earlier that you were working on hacking VisiCalc. One of the reasons Steve Wozniak attributed the success of the Apple II was that it had enough RAM to run programs like that. As we look at AI and cryptography, is existing hardware good enough? Does it need to be customized? How does that work especially for Intel? That's got to be a real concern.
So you hit right on the reason why infrastructure matters and why it's not just about the APIs and the services. The next generation of AI is really, again, as you said, it's about being able to get all the data in the right place to the right sensor to be able to make that determination. Behind the scenes, that means being able to have the appropriate storage, network, memory, and compute power to operate at those scales, at those speeds. And here's the king. It's not that you want to wait 10 days to find the answer. You want it now. Everyone wants real time. And so we see the continual evolution of the technology of all four of those areas of next generation processors year over year, getting more dense, having the 3D ability, being able to add more transistors is really about being able to power those AI systems of tomorrow. But alongside that, one of the things you find is that getting the data into the CPU becomes a key latency problem. So you need better memory architectures. And one of the things that Intel and its ecosystem have innovated is the memory architecture itself is now vastly different than your mother's memory, if you will. In the past, you had just your memory you plugged in, and that was it. You had your DDR, and that was the way you went. Well, now we have a whole new tier of hot memory that's persistent. It's called persistent memory. And what that means is that I can have memory that's right up against the CPU, operating at memory-like speeds, but I can persist things cross-reboot. And so, and it's at the scale of terabytes of data in that memory. So when you can have 32 terabytes of memory that is persistent, you can put an entire Oracle database into memory, never shut it down, and have it live the whole time.
Wow.
And that means when you boot the system, you get instantaneous response, means you can do real-time querying, redundancy, synchronization, all those features happen at speeds now because, again, it's not having to go to disk and pull it back. It's just right there. That innovation is, again, driving the next generation AI because now if I'm going to do a data set search that's petabytes of data, I don't have to wait for it to swap the data back and forth from the hard disk. I can just go right in and query the memory. Those kind of innovations are what's going to drive next generation AI. And when you look out in the future, we're going to see new innovations in memory architectures, again, bringing it closer to the processing. But we're also seeing it's not just about how can I put more data into the cloud. It's understanding that the data is generated, somewhere out there on a camera on a light pole. How do I do processing out there? So edge computing is that other big innovation area where I want to be able to do that inferencing, in the Tesla, in the car. I want to be able to know, is that a tree or not? And so being able to do that recognition and be able to do the feedback learning in that, driving data center that is a car, that requires the edge processing to be capable. what you're starting to see is, why is 5G such a game changer? It's not just because you're going to get your mobile phone to see better videos. I mean, we've got really good videos today. The game changer of 5G is when all those edge sensors can ship high-speed data amongst themselves and do that peer-to-peer mesh computing without ever having to talk to a back end and be able to do real-time response and then send the analytics to the back end. That's why we see these innovations really changing. They seem like they're independent, but they're very connected. And it's why there's so much interest today in these edge environments. And the cloud providers like Amazon and Azure have whole divisions now focused on what they call the edge stack. It's about taking their cloud and pushing it closer to the edge because they recognize that it's about being able to connect those two worlds together.
Another one that I see pop up a lot, especially in that custom hardware space, is quantum computing and quantum cryptography. Can you tell me a little bit about how that works, how maybe entangled communications work, and how that plays into our traditional perspective of cryptography?
So that's a very good question. And we could probably spend several hours talking about the amazing thing that is quantum computing.
I'm here for it.
Yes. To break it down, one of the key things about what quantum computing in general does, number one, it changes our dynamic of today. We have binary, ones and zeros. That defines everything. It's an on or an off. And even though we can pack lots and lots of information into a very small chip, it's all a bunch of ones and zeros. Quantum blows that up by adding, at the minimum, one more bit, if you will. But really what it does is an exponential leap in the amount of information per unit of information. So instead of it being one piece of information of 1 or 0, you now have multiple pieces of information that can be stored in that same amount of space. Now, the theoretical possibility is that because quantum isn't just a 1, a 0, or not, in between, it's every state between 0 and 1. It's almost infinite. As our sensors get better, we get more and more every time. So every time we add more to it, it exponentially grows in its compute power. So it's opening the doors to amazing things, whether it be computing at light speed, being able to do things that we never do because we can stuff more data in, to the idea that we can now, things like quantum entanglement, we can now communicate across vast distances without the latency of transport. And so that's some of the really cool futuristic things. One of the things that has cryptographers and security people worried around quantum is that it also opens the door to be able to doing certain key math functions much, much faster than they could be done today.
Factoring large prime numbers?
Exactly. Factoring large prime numbers, doing discrete logs in reverse. The basic foundations of modern public key cryptography were built on this notion that there were certain math functions that you could go one way really easy, but it's classified what's called an NP hard problem to go the other way. Like I could encrypt something to you with your public key and the private key, but to be able to go the other direction and be able to figure out my private key without, it's the large factoring problem. Well, there were some theoretical algorithms that were put forth, Schneier and a couple others, that stated that if you had this futuristic computer that could compute certain math things faster, you would no longer have that hard problem. Quantum is one of those class of systems that once we get to a certain number of qubits, are able to achieve really fast factorization. And when you can do that, our crypto systems as they exist today start to fall down, even with large keys. So what's happened is that NIST and the industry, and this is the international community working together, have been working on an exercise to come up with the next generation of cryptographic algorithms. And NIST, I think by the end of this year, is going to publish the winners of those new crypto algorithms that are what they call post-quantum. That means they're resilient to even having if you have a quantum computer, they're still secure. And so that's going to be, as far as fun places where math is happening, that's happening right now. For crypto engineers and for applied security engineers for the next 10 years, it's going to be taking those algorithms and applying them to everyday life. So where your browser is going to someday in the next 5 or 10 years, get a post-quantum algorithm upgrade. That also is going to entail an upgrade to your hardware to be able to handle these more complex math algorithms. One of the cool things about these math is that it's similar to what we were talking about earlier about homomorphic encryption. One of the main contenders for post-quantum safe is the lattice math, which is also the same math behind homomorphic encryption. That's one of the reasons why homomorphic is getting a lot of attention, because it would be post-quantum safe as well. And so there's going to be a lot of fun activity coming up in the next several years of applying those algorithms to everything we do, from browsers to telephones and cell phones to the internet, and getting that new generation of cryptography deployed at scale. It's going to require vastly new hardware, new memory architectures, because these mathematical functions themselves are very heavy lift on today's computing technologies. So it's going to be a fun amount of revolution in the computing architecture.
This sounds like almost Nobel Prize level breakthroughs. Is that fair to say?
I'm sure that those mathematicians think so, yes. I don't know if they would get Nobel, but there's definitely cryptography awards that they would be lined up for, yes.
Now, I've seen a lot of cybersecurity people not go anywhere near smart homes. Do you use smart devices at all? Or is that something you would never have in your house?
So in my house, we don't actually have any real smart devices, with one exception. For my small children, I did have a baby monitor, and I spent 6 months researching a camera that I thought was secure enough to be able to put in my home. And in the end, I found one. It had the right level of cryptography. It had the right access control, allowed me to change the password. And I still put it on a separate firewall VPN outside of my normal network. So yes, I don't use smart home things personally. And that one exception, I did the research. And it was funny, I found a whole community of other security researchers that had small kids and had the same problem of couldn't find a camera that met our needs. And I think we all came to the same conclusion. There was the one company that really makes security cameras for like police and so forth that actually had a smaller end version that you could use in your house.
Interesting. As a kid, were you taking things apart? Did you drive your parents nuts?
I think there were two cases where I drove my parents nuts. And one of them was your classic, I took apart the TV remote. Back then it was a big device, and it never worked the same way again. But I think the real thing that got me in trouble was, like I said earlier, I had a computer with a modem and I would talk to BBSs. It was a long distance phone bill one night when I transferred a file that it was, at the time, this was a big deal in the 80s, of a megabyte. And when they got the bill the next morning, because it was a long distance call, when they got the bill at the end of the month, I got into a lot of trouble for that one.
And then you got the brown box. What is the weirdest or strangest cybersecurity attack that you've heard of?
So that's a really good question. I want to mention two. So one was by Maggie Haruke. She published the information at DEF CON 22. It's where she used a walkie-talkie to trip ground fault, the general fault indicators on devices. So to be able to flip GFIs using a walkie-talkie and have them blow up and burn out.
Fascinating.
It was a fascinating attack that she had discovered, and the video of it is fun. Probably the weirdest or most interesting cyber attack that I've seen was a famous one from a number of years ago, where hackers got into a casinos, into their database of players via a sensor in a fish tank. And so it turned out the fish tank, like the big floor fish tank that you'd see on the floor, had a sensor that was connected to a PC so they could monitor the temperature and the acidity levels. And that PC was connected to the network. And so they used the sensor as their entry point, got onto that PC, laterally moved from the PC to the rest of the network, and were able to get the whale database going in through the fish tank.
I was going to say the casinos always care about whales, but they should have been watching their fish.
Exactly.
Last question for you. I know when I'm driving down the freeway and I see like a police car coming by, I get a little nervous with my driving. When you're around people, do they get cybersecurity paranoid?
That's a good question. In the early days, they definitely did. I remember there were, when I was doing startups, there was a certain VC that didn't want him to give me his business card because he was worried I would hack him, which of course you would never do. That would be bad form. Right. But today, I think because cybersecurity is just so part of nature, I do know that when my wife and go out and we visit with friends, oftentimes if I get talking about the stuff I do, I scare her friends.
That's fair. I scare myself when I look into it. Unfortunately, we have to call it, but Steve, thank you so much for being here.
It's been my pleasure, Daniel. Thank you so much for having me today.
Thanks for joining me in the lobby. I honestly didn't think it would be possible to go that deep on that many topics in one episode. What a treat. If it was a treat for you too, please share this podcast with someone who you think will like it. That's how we keep this going. You can also check out the show notes on allaboutscircuits.com. I'm Daniel Bogdanoff, and I'll catch you next time.